We're on problem 48. It says if x squared is added to x, the sum is 42. So let's just write that out. If x squared is added to x, the sum is equal to 42. Which of the following could be the value of x? So essentially, they just want us to solve this equation. So the easiest way to do it is to write it as a quadratic equaling 0 and then factoring it. So we could write this as x squared plus x minus 42 is equal to 0. And let's think, what two numbers, when I add them, equal 1, and when I multiply them, equal minus 42? And the fact that when I multiply them equals minus 42 tells me that one of them has to be positive and one of them has to be negative. That's the only way that you're going to, when you multiply two numbers, you're going to have a negative number. So one of them has to be positive, one of them has to be negative. And so when we're adding a positive and a negative, you're really finding the difference between the two. So the difference between the two numbers has to be 1, and their product has to be 42. And I don't know, when I see 42, I immediately think, oh, 6 and 7. 6 times 7 is 42. And since when you add them, you get a positive one, 7 is probably the positive one, and minus 6 or 6 is probably the negative one. So let's try it out. X plus 7 times x minus 6 equal to 0. And right, 7 times minus 6 is minus 42. And then 7, it's really 7x plus minus 6x is equal to positive x. So you could think 7 plus minus 6 is equal to the coefficient on x, which is 1. But anyway, that works, and you could multiply this out and try it out. And everything I'm saying, I'm not, it's not some voodoo. The reason why I say that they have to add up to the 1 is because when you multiply this out, that's what builds up this term. This 7 times x plus the minus 6 times the other x. That's what builds this term when you multiply it out, right? This term comes from the x times the x. The minus 42 comes from the 7 times the minus 6. Anyway, now we're at this point. We say, okay, well, how do we get this? We have two things. When you multiply them equal to 0, well, that means that one of them or both of them have to be equal to 0. So that means that x plus 7 is equal to 0, which would mean subtract 7 from both sides, which means x is equal to minus 7. Or x minus 6 is equal to 0. Add 6 to both sides, x is equal to 6. So x would be 6 or minus 7. And they have one of the choices there, which was choice A. Next problem, 49. What quantity should be added to both sides of this equation to complete the square? So when you complete the square, you want the thing to just look like you want whatever on the left-hand side to look like a perfect square. And what do I mean by a perfect square? So, if I had x plus a squared, that's equal to x plus a times x plus a. And that's equal to x times x, x squared, x times that a, so that's plus ax. And now this a times this x, so that's another ax, plus this a times that a, so plus a squared. And that's equal to x squared plus, we have two of these now, plus 2ax plus a squared. So essentially, we want this, we want the left-hand side to have this form. So that we say, oh, this is a perfect square. We can say that's the same thing as x plus a squared. So let's think about how we can do it. If we have x squared minus 8x is equal to 5, and I put a space here for a reason, because we want to add or subtract something here so it looks like a perfect square. So think about it. When we have this format, right? In order for this thing to be a perfect square, whatever this coefficient is right here, this term right here has to be half of this squared, right? A squared is half of 2a squared. So if we took half of minus 8, that's minus 4, right? In this case, if we said 2a is equal to 8, a would be minus 4. And so minus 4 squared is what? It's plus 16. Plus 16. And this is an equation. So one thing you do to one side of an equation, you have to do to the other side of the equation. So you have to say that that is also equal to. So you have to add 16 to both sides. Otherwise, you're changing the equation. Anyway, now this, hopefully you recognize this is already a perfect square. I mean, you could look at this pattern up here, or you could say, okay, if I add minus 4 to itself twice, I get minus 8. If I multiply it by itself, it gets 16. So this is x minus 4 squared, and that's equal to 25. And actually, just if you're curious, and we did this in the Khan Academy, we did a couple of videos on this. This is how you prove the quadratic equation. You essentially complete the square with, arbitrary numbers a, b, and c, and you get the quadratic equation. And it's not, we show it in 10 minutes, so it's not this, impossibly hard thing to understand. But if you had to, they just want to know what do you add to both sides of this equation, right? What quantity should be added to both sides of this equation to complete the square? So the answer to this one was 16. But they just as equally could have said, solve it by completing the square. And you say, oh, x minus 4 squared is equal to 25. So x minus 4 is equal to plus or minus 5. And then you could say x is equal to plus or minus 5 plus 4. And then you could say, okay, which is 4 plus positive 5 is 9. 4 plus minus 5 is 4 minus 1. Anyway, they didn't ask us that, so we don't have to spend too much time thinking about it. Let's see. We're on problem 50. Let me see. Problem 50. I'll copy and paste 50 and 51. 50 and 51. All right. What are the solutions for the quadratic equation x squared plus 6x is equal to 16? X squared plus 6x is equal to 16. And the temptation here is really to kind of try to solve it the way you do a linear equation. I don't know, factor out an x and I don't know, do whatever else. But the important thing to recognize is this is a quadratic equation. And the easiest way to solve it is to put all the terms on one side and then get a 0 on the other side. And then either factor it or use the actual quadratic equation. Or complete the square, whatever you need to do. So let's subtract 16 from both sides. And you get x squared plus 6x minus 16 is equal to 0, right? I just subtracted 16 from both sides to get here. And before just jumping into the quadratic equation, let's see if we can factor it by inspection. So what two numbers, when I add them, equal 6, and positive 6, and when I multiply them, equal minus 16. And once again, since it's a minus 16, if you multiply two numbers and you get a negative number, they have to be different signs. One has to be positive and one has to be negative. And their difference will be 6 because one's positive and one's negative. So let me think about it. So if I had 8 and 2 is equal to 16, and they're 6 apart. So if I did plus 8 and minus 2, right, plus 8 minus 2 is positive 6. So it's x plus 8 times x minus 2. And that really just takes a lot of practice. You say, okay, what two numbers? 16. Okay, 8 and 2. Well, they're going to have to be different signs. But I have a positive one here. So whichever number is larger is probably going to be the positive one. So positive 8 minus 2. Yeah, when you add them up, they equal minus 6. Yeah, it works. So you get that equal to 0. And you say, okay, this has to be equal to 0, or that has to be equal to 0. So x is either equal to minus 8, right? If you say x plus 8 is equal to 0, then subtract 8 from both sides, you get x is equal to minus 8. I shouldn't have skipped that step, but I'll do the step here. Or you could say x minus 2 is equal to 0. Add 2 to both sides, you get x is equal to 2. What x makes this term equal 0? And you can look at it from inspection. So x could either be minus 8 or 2. And that is choice C. Problem 51. Leanne correctly solved the equation x squared plus 4x equals 6 by completing the square. Which equation is part of her solution? Okay, so same thing. We just have to x squared plus 4x. And when you complete the square, you're going to add something here. So I'm going to leave a little blank. Is equal to 6. So what could I add here that makes this expression look like a perfect square? Well, we could go to the pattern that we did a couple of problems ago. Whatever's here should be the square of half of this. So 4, well, half of that is 2. 2 squared is 4. So I should add 4 to that side. If I add 4 to that side, I have to add 4 to this side as well. And now this 2 plus 2 is equal to 4. 2 times 2 is equal to 4. So this is x plus 2 squared. And I really want you to get the intuition. Don't memorize the steps for completing the square. I want you to really understand why this is the square of half of that. And we showed it in the beginning. Square a lot of binomials and see for yourself that that's always going to be the case. Anyway, so this is x plus 2 squared, and it's going to be equal to 6 plus 4 is equal to 10. And that is choice B. Choice B. I think we have time for one more. One more problem. Problem 52. Copied it, and now I have pasted it. Carter is solving this equation by factoring. Which expression could be one of his correct factors? All right. Once again, I like to personally separate out a number that goes into all of them, and all of these are divisible by 5, and that just simplifies it in my head. So if I divide all of these by 5, actually I can just divide both sides of this equation by 5, right? 0 divided by 5 is 0, and then the left side divided by 5 becomes 2x squared minus 5x plus 3 is equal to 0. Okay, so this is 2x squared here, so it's going to be two numbers. When you multiply them, equal 3. And when you, so let's think about this a little bit. Let me write it down here because I think I'll need more space. 2x squared minus 5x plus 3 is equal to 0. And I just divided both sides of this equation by 5 to get to this. So let's see what we can do here. So we have a 2x squared here, and they already kind of hinted us that we're going to have an integer solutions that we can factor this. So the intuition is that this is going to be 2x times, plus something, plus a, times, well, what times probably x, right? 2x times x is 2x squared. Now that wouldn't be completely obvious if they didn't already tell us that, we could factor this. You might have to use a quadratic equation or something. Actually, the quadratic equation wouldn't be something crazy to use here because you can just kind of plug and chug. But let's see if we can get the intuition. So it's going to be 2x plus something times x plus something else. And if we were to multiply this out, you get 2x times x is 2x squared, as it should. 2x times b is plus 2bx. A times x is plus ax. A times b is plus ab. And so let's see what we get. We get plus 2b plus ax plus ab. 2x squared. Okay, now we can do pattern matching, right? This was our original thing. So 2 times b plus a have to be equal to, right? This term is the same thing as this term right here. And that term has to be the same thing as that term right there. So what two numbers? So first of all, I have a positive 3 here. So I'm multiplying two numbers to get a positive 3. So they either have to be both positive or both negative, right? And then the other interesting thing is we have, when I take 2 times one of them plus the other one, I get a negative number. So the only way when you're dealing with negative numbers, and when you just multiply it times a positive and add them to each other, you get another negative number, is if they're both negative, right? This told us they both have to be negative because this is positive. And then since when you add them in a kind of, without any negative signs, you get a negative number, it tells you that that has to be negative as well. So let's see. Let's just try negative 3 and negative 1. So if we have negative 3 and negative 1. So you're right. Yeah. If b is equal to minus 1 and a is equal to minus 3, then 2 times minus 1 is minus 2 minus 3. Right. So b is equal to minus 1 and a is equal to minus 3. And so this is a bit of an art form here. I mean, there isn't like a plug and chug, very mechanical way of doing this. The quadratic equation is 1, but this is the best way that at least I know how to do these without. So we know what a and b is. So it's 2x. A is minus 3. 2x minus 3 times x plus b. B is minus 1. So that's the factorization. And what are they? So 2x minus 3 times x minus 1. Which one? They have this one right here. 2x minus 3. And I'm all out of time. See you in the next video.